Recent advances have brought about a fusion of interactive technology, humans and water, shaping what we now call WaterHCI. Our exploration into WaterHCI design has unveiled a myriad of possibilities, from augmented reality systems to snorkels to underwater musical instruments for artists. At the core of WaterHCI lies the intersection of water, humans and technology. It's a realm that has evolved from the early vessels to modern interactive systems. Early examples like Swim and Aqua Centauri paved the way for a diverse range of aqua-HCI or water-HCI innovations, including devices for rafters, virtual reality headsets for water slides, and even underwater camping tents. While there are numerous opportunities to enhance water-based experiences, there are also significant challenges. WaterHCI researchers are uniquely positioned to address them, from designing implicit aquatic interactions to overcoming environmental constraints. What are the grand challenges for facing WaterHCI, and how can we address them to propel the field forward? Our journey begins with the collective efforts of 17 experts in the field of WaterHCI who convened for a workshop during a premier HCI conference. These participants, hailing from various backgrounds and countries, brought with them a wealth of experience and expertise in designing, evaluating and analysing WaterHCI systems. Their insights and discussions formed the cornerstone of our exploration into identifying the grand challenges in WaterHCI. Through a multi-step process, inspired by prior works and workshops with analogous aims, we embarked on a journey to articulate the most pressing challenges facing the field. After extensive deliberation and refinement, we identified 4 grand challenges in WaterHCI that warrant attention and innovation. First, we address the critical need for waterproofing technology, essential for ensuring the safety and functionality of interactive devices in aquatic environments. This encompasses considerations such as IP ratings, custom sensing, and maintaining interactivity while safeguarding against water damage. Next, we explore the development of hardware optimization for WaterHCI, focusing on buoyancy, robustness, and connectivity, because these pose unique challenges in the aquatic environments, demanding innovative solutions for seamless interaction. Our third challenge centers on harnessing water as an interactive material and unlocking its vast potential for immersive and intuitive experiences. Sensing water displacement and enhancing the human body's interaction with water presents exciting avenues for exploration and innovation. Toolkits for prototyping WaterHCI devices. HCI research has developed many toolkits to enable novel interactive experiences. In keeping with this work, we contend that toolkits could encourage and embrace WaterHCI to enable novel aquatic experiences as well. We begin by looking at the evaluation framework for WaterHCI experiences. Evaluating WaterHCI experiences poses unique challenges. For example, evaluating while users are immersed in water can be difficult, as participants may find it challenging to report their immediate, visceral responses. Evaluation of WaterHCI experiences requires addressing unique challenges related to the aquatic environment and also to the participants who are engaged and active in these spaces. By understanding these challenges, we can design more effective and inclusive WaterHCI systems. Now let's explore how to support human senses in aquatic environments. Vision, hearing, touch, and even smell is affected by water. Interactive designers must adapt to these sensory changes to create effective WaterHCI systems. Thirdly, the challenge of sharing aquatic experiences. Engaging with water is very often a social activity. However, when it comes to interactive technology support, there are not many examples beyond apps. However, notable exceptions are, of course, with AR snorkeling experiences that have been enjoyed in groups and floatation experiences that allow participants in different floatation tanks to sing together via internet-connected microphones. Transitions into and out of the aquatic environment are also something that most users will be familiar with on a land interaction system. However, they will be likely different with WaterHCI systems. Hence, it is a challenge to switch between the coming and going of land-based interactions to the aquatic domain and back and forth. We first look at designing implicit aquatic interactions. Most aquatic interactions require a user's attention and bodily engagement in submersion. Rather than performing swimming strokes to stay afloat, for example, interactions with technology will often not be the primary factor or focus. Rather, they may just operate beneath the user's conscious level. Designing shared agency with aquatic tools. We find that many aquatic activities involve some type of tool, for example, a kickboard, a surfboard, or an interactive robotic tool. We believe that there is an opportunity to seize the emerging advances around artificial intelligence and actuators to give these tools some agency. An autonomous underwater vehicle that cooperates with the human is a great example. And overcoming the constraints of the aquatic environment. There are numerous realities to the aquatic environment that must be considered in augmented reality, virtual reality, for example, or the technological interface that the human is experiencing both one world and another simultaneously. Exploring WaterHCI for sustainable practice and WaterHCI as sustainable practice. WaterHCI systems not only need to address power consumption and e-waste, as traditionally discussed in HCI, but also water source, use, waste and pollution. In addition to that, we are looking at applying WaterHCI safely. Having people interact with water raises many ethical challenges about safety that affect the researcher's practice. Addressing these is an essential part of bringing the field forward. That applying technology to any environment not only alters the interaction in that space, but the environment itself. Finally, overcoming the divide in terms of accessibility to water. People already have an unequal access to water, not just for drinking, but also for aquatic activity, mostly through geographic locations, but also as a result of political, financial, or physical limitations. And finally, in addressing cultural factors. With regards to sharing of facilities and specific clothing to be worn, for example, or cultural sensitivities around access to opportunities and body biases that we may see in body-centric devices. As with any research endeavour, our work has its limitations and points to avenues for future research. We welcome, of course, additional voices to enrich our discourse. We recognise too our privileged position with access to waterways and technology, which may not be shared by researchers all around the world. Our identified challenges must be approached with inclusivity and awareness of diverse perspectives. Addressing these challenges will require interdisciplinary collaboration across engineering, social sciences, water and marine specialties, and the HCI communities. Thank you for joining us in exploring this exciting potential of WaterHCI. Together, let's propel the field forward and unlock its creative collective capacity to benefit humanity.